In this video, we're going to talk about absolute error. So suppose we have a projectile. We've got a formula here for the range of that projectile based on its initial speed and the angle of inclination. So let's say that we're given the angle of inclination 30 degrees plus or minus 1 degree. And let's say the initial speed 3 plus or minus 0.2 meters per second. Based on that, we want to find the maximum error in the range. So to do this, we're going to calculate the differential of the range. And before we do that, I think we'll just flash back to differentials in general. So if we had a function f that depends on x and y, we'd say the differential of f is df, and it's calculated as f sub x times dx plus f sub y times dy. Now in this problem, the notation is a little bit different because our function is not f, it's r. So we're going to say dr. And r depends on two variables, which are the angle and the initial speed. So we're going to say r sub v0 times d v0 for our first term, and then r sub theta plus r sub theta times d theta. So that gives us the differential of r. And that's what's going to speak to the absolute error in the range. So let's try our calculation. We're going to take the partial derivative of the range with respect to the initial speed. So that's going to give us 2v0 sine 2 theta over 9.8. Remember, theta is just a constant when we're differentiating with respect to v0, and then that will be multiplied by dv0. Plus, now we'll take the partial with respect to theta. We're going to have v0 squared. Derivative of sine 2 theta is 2 cos 2 theta. That's still divided by the constant 9.8, and that's going to be times d theta. Okay, and that is giving us our dr. So from here, we're going to try to figure out what values to sub in. Let's keep in mind that our goal is to maximize dr. So we're trying to figure out the maximum possible error in the range. So we're going to try to maximize dr. And let's talk first about what value of theta and v0 to plug in. So for your values of theta and v0, just use whatever estimate is given in the problem. The estimates were 30 degrees for the angle and 3 for the initial speed. And then we need to talk about d theta and dv0. Okay, well, when it comes to error is always given as plus or minus a certain quantity. We're going to keep it simple and just use the positive quantity, and because we want to maximize dr, we want to use the maximum positive value for the error, which would be 1 degree for d theta. But because d theta is going to be outside of a trig function, we need to express this in radians. So let's convert over to radians and just call that pi over 180 rads. For the theta itself, because it's going to be inside a sine or cos function, you can leave it as 30 degrees. You don't necessarily have to convert it over to radians, but d theta certainly needs to be converted over because it's outside of a trig function when we evaluate it. All right, and same idea for dv0. We're saying the maximum error in v0, 0.2 meters per second. So that's the value that we'll sub in to maximize dr. And then we're going to figure out how big that error in the range can be. So let's try subbing everything in. When I sub in these values here, we can now call this dr max. Can just put a little subscript there to indicate this is our maximum error, and let's see what we're getting. So we'll have 6 times sine of 60 degrees over 9.8 times the dv0, which we decided was 0.2, and then plus we're going to have 2 times 3 squared is 18 times cos of 60 degrees over 9.8, and then times our d theta. So this is the part where we really need radians, pi over 180 radians there for the d theta. So if we plug that into our calculator, it comes out to about 0.1 meters And you may remember from our previous discussion on differentials that the actual change in a function, or the actual error in a function, is delta f, whereas the way we calculate that is using the differential. So df is the approximate error, whereas delta f is the actual error. So in this context, delta r is the actual error, and we're approximating that by dr. So based on that, we can say the error in r, delta r, max is approximately 0.1 meters. And then when we give our answer, we could say something like the maximum error in the range is plus or minus 0.1 meters. So you would get the negative error if you had, in your evaluation, actually used the minus 1 degree for the d theta and the minus 0.2 for db0. So you could be off by 0.1 meters in either the positive or negative direction. And that gives us our answer. So that was some practice on using differentials to calculate absolute error. We're going to talk about relative error in our next video. Thanks for watching.